you're very welcome to this webinar today, where we're going to be looking at exploring engineering in Trinity College Dublin. My name is Kevin Kelly. I'm the Director of Undergraduate Teaching and Learning in the School of Engineering, meaning I have responsibility for a number of programs. We're joined by a couple of other people on the call here. So we've Melanie May from the E3 team, who looks after our admissions across the E3 program. And we've two students, Maya Woolaver and Simon Connell, who'll be happy to answer some of your questions in the later part of this session. We'll also be joined by another academic from the School of Engineering, Sarah Pavia, who's just been a little delayed. So I'm just going to begin matters by going through a short presentation for about 10 minutes. Welcome, Sarah. And during that presentation, I'll just talk a little bit about options in the School of Engineering. So I've introduced myself. We have Dr. Sarah Pavia, then from the discipline of Civil, Structural and Environmental Engineering. My own background is in mechanical, manufacturing, biomedical engineering. And then Maya is in her fourth year studying electronic and computer engineering. And Simon is in his fourth year studying engineering with management. So a little bit about the School of Engineering. It's one of the oldest engineering schools in the English-speaking world. Founded in 1841, but it's also a very modern research-led school, consistently high in the world rankings. So our peers like what we do, and industry likes what we do. And being research-led means that our academic staff are involved in cutting-edge research. Many are involved in commercialization of that research. We have strong links with both industry and academia locally and internationally. And they're bringing that expertise then also into the classroom and the experiences that we're able to provide to students. All our programs are accredited, meaning that you have a recognized professional engineering degree, which is recognized internationally. And in our case, because we're in Ireland, those programs are accredited by Engineers Ireland, but that is a transferable qualification that enables you to work as a practice as an engineer around the world. So let's go to the next slide. So I'd like to just talk a little bit about the context that engineering exists in today. Is a little different than maybe it has done in past years, and maybe a little different to the context in which it exists in other universities. So in Trinity, engineering is part of an initiative called E3, and the three E's referred to in the E3 are engineering, environment, and emerging technologies. And the goal here is to bring various disciplines. In our case, we're looking at three core disciplines, being engineering, natural sciences, and computer science, and looking at those three disciplines working together, and where appropriate, bringing in other expertise to try and create balanced solutions for a better world. So we're future looking, but we're also interested in balance here. So we have to think about sustainability, and we have to think about climate, and we have to think about a lot of these really important drivers and how technology can coexist and indeed create perhaps solutions for some of these existential challenges we face today. So it's a new reality. So E3 involves a number of different strands. Not sure if we're playing a video on this slide or we're just moving on to the next one. So one of those strands is a new building, which will open in the next couple of months. So it's 7,000 square meters of a building directed and designed solely for the teaching and learning experience. So there are no academic staff offices, there are no research labs in this building. It is a building that has been designed to provide the best-in-class student experience for students in the E3 disciplines over the next 15, 20 years. So we put a lot of effort into this, and we think it will be an iconic building that people will reference in other universities, other parts of the world, as the way in which engineering, technological and natural science education can be given. So there are key features of the building in terms of the space and the number of spaces designed specifically around student needs. So a lot of places where students can work in small groups. There's a lot of project working spaces. There's a maker space, and then lots of other spaces like you would see in other buildings, but just hopefully better versions of, in terms of lecture theatres, laboratories, and computer rooms and so on. So that's coming very soon. So any new entrants in 2025, you'll be starting your career in that building. So moving on. This is a rendering of the inside of the building. This is just after you come in the main door, and on the in front of you as you look at this picture, but on the left after you come in the door, those white will look like cupboards. They're racks of 3D printers. So we have about 40 3D printers sitting there, which students will have access to. And then there's various project working spaces. And at the stone wall, you can see in the background, that's the entry to the maker spaces, where there'll be lots of machinery and tools which students will be able to use to pursue their own learning. So not just in the classroom, but also outside of the classroom. So a lot of opportunities for students to develop their own skills. We move on. We have three different routes into engineering within Trinity. Our largest cohort and our longest open program is the general engineering program. I'll talk a little bit more in the next slide about that, but it's a common entry program, meaning that you enter as a general engineer, and during the program, as we'll see in your second year, during your second year, you choose which of those particular streams, 6 different options you can choose for your third, fourth, and indeed fifth year. And then we have 2 programs that we would call direct entry programs, meaning that you are choosing a particular type of engineering that you do. We have the engineering management program. So that concentrates mainly on mechanical manufacturing engineering with a little bit of biomedical, and has significant business management component as well as design. So Simon, who's one of the students on the call today, is in that program, and Maya, who's the other student with us today, is she is in the general engineering program in the electronic and computer engineering strand specifically. And then we have our newest program, the environmental science and engineering program. And this, as the name implies, is focused around environmental engineering and environmental science. And this is jointly taught and managed across the School of Engineering and the School of Natural Sciences. So it's an interesting and quite unique program that allows students later in the program to specialize in either environmental engineering or in environmental science. And really the difference between those, I suppose, is that environmental engineering will be more applied. We'll be looking at creating solutions and designing systems in the environmental area, and environmental science is more focused on knowledge and understanding the environment around us. So move on to the next slide. This is a schematic which explains our structure in the general engineering program, and we can use that then as a jumping off point to understand the structure in our other programs. So you'll see here that we have modules, meaning subjects, essentially, that you study in first, second, and third year. Noting, as we said before, that the third year is a choice point in the general engineering program at which you can choose one of the different disciplines. But viewed through this prism, all of our programs share the same structure. So years 1 to 3 are based in Trinity exclusively, studying various different modules. Then you have a number of choices for what comes next. You can elect to leave with a bachelor's degree. So that's a level 8 honors degree, in which case your year 4 experience, as shown in the top in blue, consists of some subjects and what's called a capstone project. And a capstone project is an individual project that you undertake under the guidance and supervision of a member of academic staff, designed to integrate knowledge from a broad range of areas in the program. So it's a personal, individually directed project that brings together, integrates all your knowledge. And then that allows you to leave with a bachelor's degree. If you choose to stay on our master's path, it means you've got 2 more years. And in that case, your capstone project is done in the 5th year, and you have a range of different options that you can do in the 4th year, ranging from just taking individual modules. We also have an internship option, which allows you to work in industry for a number of months. We have a study abroad option, which can be for half a year or for a full academic year. And then we have at the bottom there something called Unitech, which is almost a combination, if you like, of study abroad and internship. So you spend 1 semester in a country in Europe, in one of a number of partner universities in Europe, and then you spend 6 months after that working in an industry in another countries. So you get experience in 2 European countries, one in the university and one in industry. And all our internships are paid, salaried internships. So we move to the next slide. So in the environmental science and engineering program, 2 common years, and then you can specialize in the environmental science stream or in the environmental engineering stream. So if you go with the environmental engineering, it's quite similar to what we talked about on the previous slide. So you can look to go a 4-year route, exiting with a bachelor's degree, in this case a BSc in environmental engineering. You can do an industry internship, you can do international exchange, and you do modules. And then if you go the environmental science route, again, you have quite a similar structure there. Also, the 5-year option in both cases, either a Master of Arts in Environmental Science, the MAES, or the MAI, which is a Master of Arts in Engineering. And the I there is because we use the Latin word ingeniare for engineering. So Master of Arts in Engineering is the MAI. Okay, we move to the next slide. So this shows, the previous slide was our environmental science and engineering. This is both the general engineering program and the engineering with management program. So you can see the main difference there, I would say, other than the class size, which is something I'll come back to maybe in a minute, is that there's more management science and business in the first 2 years of the engineering and management program, but both programs basically use the first 2 years in an engineering sense to build a foundation in the fundamentals. In the general engineering program, you then opt for one of the specialisms, as we've mentioned earlier. And in the engineering management program, there's core content, and then you can choose a minor specialism in either mechanical engineering or biomedical engineering. So, and again, there are options to leave after 4 years or after 5 years with a master's. We move on. Study abroad options then, these are available for our students on the master's track. So if you elected to leave with a bachelor's, you do not get the study abroad option or the internship option. They are only for the people on the integrated master's program. So our study abroad options are in 4th year, and that can be for a single semester or for both semesters. We have a number of options in Europe, but we also have options in other continents around the world. So North America, South America, Asia, Australia, Australasia, etc. The Unitech program, I've mentioned previously, that's like a combination of the internship and the study abroad programs, and there's lots more detail is available on those, and we can also take any questions on those. So we move on. So these are examples of some of the companies here that our students have gone on internship to. Typically, these internships begin in January, and they're formally conclude in May for assessment purposes. They're part of our curriculum, and but students are also paid. So it's very common for students to continue working into June, July, and sometimes even into August. So a lot of students build up a lot of experience that way, but it's also a chance to earn some money while doing your degree program. And then we've mentioned the Unitech option previously. So we move on. These are some of our engineering students. I'm not sure exactly how this chat works. Melanie, you can add something if I've got it wrong. My understanding is that these are opportunities to have an asynchronous chat, is it, with these students? I ask them questions and they'll respond.
Absolutely, absolutely.
Yeah.
This is giving prospective student a chance to connect with our current students to hear their experience. So I would strongly recommend to utilize these opportunities to engage.
Yeah. And you'll see there just from the graphics on screen that we've tried to select students from a range of different backgrounds. So many or most of you listening in today will be joining us from outside of Ireland. So it's normal and perfectly reasonable that you may have questions about what it's like to study in a country like Ireland, and what are the experiences of being in the Irish education system. So you have some people who've come through the Irish education system, but you people bring in a range of different backgrounds, as you can see from the slides there. So hopefully that will be of help to you. We move on. So applications are open now. So if you're an EU applicant or a European Economic Area applicant, then you apply through an organization called the CAO, the Central Applications Office, and that's a company, if you like, that manages the applications for all Irish universities. So that's the process for all EU and European Economic Area students. If you're applying from outside the EU, then there's a different application process, and the key points are outlined there, and also there's links to find out more details about the process. Move on to the next slide. There are scholarships available, and we may be able to answer questions on those if there are any. So we have scholarships which are automatically awarded based on the grades that you present at your entry to university, and that applies across the university. So they're available to all EU students, and then students from a non-EU background. We have a number of scholarships. So we have the Global Excellence Scholarships, which is a sum up to €5,000, and that gets deducted then from your fees. And we also have a number of scholarships within the E3 program to incentivize students to join us from outside Europe. And then all students, once you're in the system, we have something called a foundation scholarship. So this is currently awarded on the basis of examinations in the second year, which are optional. You can choose to sit them or not sit them, but if you wish to be granted the scholarship, then you have to sit them. If you sit those exams and you do sufficiently well, then there's quite significant benefits that you get. Reduced fees, accommodation and food on campus for the remainder of your undergraduate program. And that gives you quite a prestigious award that you can then put on your CV. We move to the next slide. And that's the end of that part of the presentation. So at this point, I guess we can potentially go to some questions. Melanie, I think at this point, I will be moderating the discussion. I can contribute answers to questions, but what I'll do is maybe if you can pass any questions to me, and then I will maybe comment and ask one of the panel members to comment on those. And just to remind everybody who we have here, we've Professor Sarah Pavia, who's in the discipline of Civil Structural and Environmental Engineering. And we have Maya, who's a fourth-year Electronic and Computer Engineering student, and Simon, who is a fourth-year Engineering with Management student. So Melanie, do you want to throw us?
Yeah, absolutely. Thank you so much, Kevin. And so as part of the registration, we have pre-collected a number of questions. So I'm just going to raise those questions as per the topics. So we have one question received asking, how does the curriculum balance theoretical knowledge and practical skill development? Do you know how many, for example, lab design projects, how many modules, or how these modules are assessed?
Okay, so that's a pretty broad question, and maybe I'll try to answer it a little bit myself, and then I'll maybe pass to Sarah, who can talk perhaps about some examples in her area, and then I think really the voice of the students would be very relevant here, where they can talk about some of their own practical experiences. So the first comment I would make is that we formally identify in our timetabling laboratories, tutorials, and modules. Some of the modules will have a lot of practical work. Some will have very little practical work. Most modules, but not all, will have a laboratory associated with them, which is inherently practical. But we would have a lot of design modules, for example, where students would work in teams and would have to work together over extended periods of time on projects that can be anything from quite conceptual projects or desk-based projects up to things that are highly practical and physical, where there's creating physical artifacts or pieces of code or circuits or scale models or computer simulations, a whole range of activities there. So I couldn't give you an exact figure because well, one, I don't know the exact figure, and two, I think that will vary a lot depending on what you choose. One of the things that maybe we haven't mentioned is that there is a lot of individual student choice, particularly in the fourth and fifth years of the program. So students may elect for some students might end up taking a lot of modules that have practical work, and other students may take fewer modules. I think it's important to state that practical work is important for engineering, and any program that doesn't have some level of practical work, I would say, it's challenging really to brand that, I think, as a modern engineering program. But equally, a good engineering program must teach students the fundamentals of the theory that allows us to know what we can do and what we can't do, and how to approach the practical implementation side. So they're complementary to each other. It's not an either or. Sarah, I don't know from your own discipline if you'd like to add anything there about the practical work.
Yeah, I can tell you a little bit about the practical element in civil engineering, because as Kevin said, well, the first 2 years, even the third year, there is theory and laboratories. But on the third and the fourth and the fifth year, there are also a lot of science. So site work, site visits, and in the laboratory, there are a lot of practicals where you work with materials. Your projects in fourth year and fifth year, individual projects, they are largely practical as well. They might involve laboratory, or they might involve your own background research, but they will be quite very much focused on practical ability, and on also expanding your ability to do your own research, your own background research, to work in groups, to look for solutions to practical problems. So even if you are using theory and you are using library resources, you'll be focusing on something specific that most of the times is aimed at answering some problem or looking for some solution. So I agree with Kevin, like it's largely practical, and I cannot give you a figure. Like, for example, in some of the postgraduate courses that we have, even like the postgraduate diploma, the 1/3 of the course will be practical based on labs and site. And our undergraduates, maybe it might be, I mean, don't take this as an exact number, but maybe I'd say 1/3 at least will be practical, in my opinion, or more.
Thank you, Sarah. Maya, maybe I could come to you just if you'd just reflect briefly on your own experience. It doesn't have to be a comprehensive overview, but just probably recent is best. So in your current year or in your third year, just examples of practical work that you've been involved in.
Yeah, now we specialized, we get to choose kind of more of our courses. So I like to do the practical stuff. So we've picked some labs where one of them in particular is you choose your own sort of research project in the electrical and computer engineering scope, and you just spend the entire semester working on building this. So like, for example, I built an audio synthesizer, and some other people built heart rate monitors. And so you get a lot of hands-on practical lab time that they give you for that. But anytime that you have a course, in my experience, that is theory, you always have labs that are taking the theory and then applying it. So for example, you might learn how to do digital signal processing, and then you go into the lab the next week and are given actual digital signals, and you have to process them and find out what works best. So you get a good mix of any theory you learn, you generally get to apply it in some sort of lab, which is nice.
Thanks, Maya. And Simon?
I guess just to kind of echo what Maya said, the standout part for me is the integration between the practical work and the theory, where some semesters you might start, and normally towards the start you can be given an outline of what the module will look like. So you can almost see your final project, and it might be due towards the end of the semester, but you'll get started on it right away. But you'll find that throughout the module, you will be working towards it, both in the lectures and the tutorial material, developing your understanding. And by the time the end of the module comes around, you'd be surprised at how much you learn. So, I mean, an example of this, I have multi-body dynamics this year. And so it's just basically how a lot of linkages interact with each other, but then that can be applied in robotics and how robotics move. So normally I would never have thought of myself as someone who is really, that would be my strength, but through the course and through the labs, we all got to develop kind of a pathfinding system for a robotic arm. So I guess that's kind of my example of how the theory and the practical element are so closely linked and how they're thought.
Great, thanks, Simon. Melanie, do you want to give us another question there?
Yeah, no, thank you for those answers. So the other question I have here is, are there opportunities for our students in engineering to collaborate with students, say, from other disciplines or departments? And, you know, how do we sort of foster that sort of interdisciplinary education and encourage sort of teamwork?
Yeah, that's a good question. I think there are a couple of components to the answer. I think it's probably best if wearing my Director of Undergraduate Teaching and Learning hat, I answer this one myself rather than passing it around. I think what we have currently within the curriculum are a number of examples where students could get an opportunity to work on a topic that is relevant to, and in some cases will have students from other disciplines working on it. So that could be engineering by its nature is quite an applied discipline. So you're a problem solver, and you don't just solve problems for other engineers, you solve problems for people, and people have a range of different needs, from medical needs to clean water to food to transportation systems. So you could be working with colleagues in those. So they're what I would call maybe soft linkages or soft overlaps with other disciplines. There are a few examples. One that comes to mind would be in the latter years, we have an elective module called Innovation in Product and System Development. And in that module, we collaborate with other universities and with industry and external stakeholders to create real solutions. So that's an example of working across disciplines. And then I would say for students coming in to university at the moment, I mentioned the E3 Learning Foundry. So that will, I think, substantially increase our capacity to facilitate multidisciplinary working outside the core curriculum. So we have a number of activities where students are currently engaging. I could give you one example would be Formula Trinity is a student club and student activities centered around race cars. And we have, I think the last figure I heard was about 50 students or 45 students involved in that, but students from across the university. So there's people looking at the marketing and business side of that and raising money, and there's people looking at, you know, the mechanical construction. There's people looking at the sensors and control. There's people writing code. There's people looking at every aspect of that system. So that's a very multidisciplinary learning experience that happens outside the curriculum, but is facilitated to a greater or lesser extent by facilities and in some cases staff involvement. So the Learning Foundry will give us physical space to see a lot more of that. And it's one of the reasons we put in a makerspace that's available to all, and we've located that on the ground floor where it's highly visible. And the idea is to encourage students across the E3 schools to engage together and to be able to work alongside each other and interact with each other. So that's the informal part. And then there is also because we will have this new building, we are also working at evolving the curriculum. So we're actively designing in multidisciplinary project experiences for students in the future. So even though we don't do very much of that in our current curriculum, a lot of that is down to practical reasons around space and facilities. And the Learning Foundry coming on stream next year will allow us to bring a lot more of that formally into the curriculum from the earliest stages onwards.
Right, we are really encouraging that sort of interdisciplinary and collaborative approach. I see we have Farouk who have raised their hands. I don't know, Kevin, will we ask Farouk, do you have any specific question to ask?
Yeah, hello. Am I audible?
Yes, you are.
Yeah.
Hi, Kevin Kelly. Thank you very much for this wonderful presentation of introducing TCD to us. I have two sons, and one of my sons is studying industrial management at a very prestigious college in India. That's IIT Kharagpur, if you have heard of that.
Yes.
And I have another son who is in grade 12 here, and we in Indian context we choose the careers after grade 12. And I'm seriously interested in sending my son to TCD for some computer course involving AI, data handling, and data management, things like that. What I'm interested about is to how much would a an undergraduate course cost if I send my student in the September 2025 intake?
Maybe
Yeah,
I
I think
could
you could probably
answer
take
that,
that. Yeah.
Farouk. So, in terms of the tuition fee, typically for non-EU students, you're talking about 20, I think 28,000 euro approximately. That's the annual fee, and applications opened, and so if they're ready to join September 2025, they can submit an application now.
That would be, you said 28,000 euros. That would be for 1 year or
Per
the
year,
entire
yes.
course per
Yes.
year.
Yeah. Yeah.
So the undergraduate course is for 4 years or 3 years?
So our
Our
bachelor degree
graduate
is
programs
4 years,
are
and
4 years.
with the optional year
Okay.
to go on to do year 5 and to obtain a master's qualification.
Okay, I understand that. Thank you
Okay.
so much.
You're very welcome. Kevin, I see some questions in the Q&A box. I'm just to go through them.
Sure.
So Clash asked, what kind of engineering design or project do students typically work on in their final years? So perhaps Simon and Maya could share their insights with us.
Yeah, so maybe I'll just tee this up by saying final year is a choice. Your final year can be your fourth year if you're exiting with the bachelor's degree, or your fifth year if you're exiting with the master's degree. So not every student will get a project in fourth year, unless students who are leaving with the bachelor's will always have a fourth year project, but students who are continuing to the master's degree in fifth year may not have a project. The projects are not necessarily design projects. So some of the projects would be more research and testing projects, so experimental projects, or some would be simulation projects. There are some projects that are based on design, but that's not it's not the only type of project we have in terms of a capstone project. In more general terms, I'm not sure whether your question was focused on the experience of design or focused on the experience of the capstone project, but hopefully I've answered it from the perspective of the capstone project. From the perspective of design, typically in the first 2 years, you'll have a lot of design experience, but as you would imagine, you're only beginning to develop your skills. So some of those design experiences are focused more on learning the what we would call the transversal skills. So that's, working in a group, communication, time management, planning, budgeting, things like that. And as you move to later points in the program, in the second and third year, you're expected to leverage more of the technical content in the design. So a lot of the what would I say, the mandatory content that involves practical design is in those first 3 years, and then there are some optional content depending what choices you make in your fourth and fifth year where you can have further design experience. So hopefully that answers your question.
Great. And we've questioned from Mavika asking, would you be able to give some idea on the percentage of students who have got internship in the last year? So do we have data on that?
I can't give you an exact number as a percentage. It does vary a little bit by discipline. And I just remind you, the internship is not mandatory. So it's first of all, the internship is only available to people who are on the master's track, not people who elect to leave with a bachelor's degree. There are other options for people on the master's track. So students, for example, can study abroad, or students can choose just to do modules and not do the internship. And we do have a qualification requirement. So we require students to have at least a 2-1 qualification, which means a 60% average to be eligible for the internship. So the number I have from last year, I think, was 122 students, if memory serves. It's of that order, about 120 students who engage in an internship. The total number of students in fourth year across bachelor and master's is probably of the order of 200 or 220. So it's an absolute minimum, I would say, therefore, of about 60%. But in reality, it's higher than that, because some of those students are either not on a track to take an internship, or have elected for, chosen not to do that. So it's probably closer to 75%, I would say, of our students who want to do an internship and do get one. So it's a relatively small number who would like to do internships who don't get to do them.
Great. So this is a question for our students, actually, Simon and Maya. What were your favorite things so far about studying your course, and also any tips about, for somebody who's thinking about maybe studying engineering at Trinity? What sort of tips do you have for them? So maybe Simon first.
Yeah, I guess if I had to pick a favorite, it would probably have to be something with one of the design modules. I know I've chose the engineering with management stream, so it's a smaller course size than the general engineering stream. It's about 25 to 30 people in my course. So when you're doing group work in the first 3 years, you really build a good understanding, and you get to work with the same people quite often. So I find that the design modules are always a lot of fun, because they incorporate the analytical and the theory skills that you learn from other modules and the fundamentals of engineering. But then the part that I like is the kind of more creativity side of things. So I really like that. And if I had to give advice, probably just keep an open mind, not just with engineering, but in terms of the whole college experience. Give everything a try, and you never know, you might surprise yourself.
Maya?
My favorite part about doing the engineering course here at Trinity was actually that I got to do the first 2 years general, because I was really indecisive and not sure what kind of stream of engineering I wanted to go into. So I found that coming here gave kind of a really wide range, getting to see what all the different streams are like. And now I'm really happy with my decision to go into the electronic and computer stream. So I found that kind of getting the chance to basically try everything out and see what you like was a really good experience. And now I get to do labs that I'm really interested in, rather than trying to force myself to do a stream of engineering that I wouldn't have previously been interested in.
Thank you very much. So my next question is maybe for Kevin and Sarah, that how do you see the field of engineering evolving in the coming years, and how is Trinity preparing students for these changes?
I'll pass that one to Sarah. I'm happy to add to it later, but I think I've been speaking enough, so let Sarah speak first on this one.
I would say that engineering is very dynamic discipline, and a very dynamic discipline that is changing all the time. Like, for example, in the case of civil, the civil engineering stream, we have management, hydraulics, transportation, geotechnical engineering, structures engineering, highway surveying, fluids and environment, waste treatment, solar energy. So it's so wide and so multidisciplinary in itself. And every time, like, the new problems are coming up, for example, carbon emissions now and climate change. Well, we have all this research and modules on alternative energies, on waste management, on pollution, air pollution, water pollution. low carbon cements made with waste, and like how to explain? It is constantly moving and constantly adapting and constantly revolving, because a lot of, like, most of us, all of us do research, and we feed this research into our modules and into our projects. A lot of our 4th year and 5th year projects and master projects are linked to our own research projects, and sometimes even working with industry in those. So it's continuously getting updated and changing. It's very dynamic, and it has a lot of application and many possibilities for working in many in multidisciplinary areas.
Yeah, I would add to that maybe that the only thing that doesn't change is that there is change. So if it sounds like a contradiction in terms, but it's something you get used to as an engineer is that nothing stays static. So there's always new technologies, there's always new requirements. If I was to call out specific examples, I think that are there right now, AI is obviously a big technology that's there, that's impacting how a lot of us can live, will live. And there's a lot of interesting dimensions to that and applications of that in a whole range of different areas. But engineers ultimately are responsible for bringing technology to people in the form of, products, services, devices, systems, and we are finding ways and new ways to incorporate things like that. I think there's a few other trends. Climate and sustainability is huge. I think it means engineers have to find clever new ways of doing things that use less energy, that use less materials, that our systems have to be designed for reuse, for disassembly, for recycling. So those are challenges that are there. I think there's technological solutions from nanoscale up to mega scale around health and around climate and energy. So, can we, as well as being more efficient at what we do, there are also really big picture solutions around carbon capture, around energy generation. You just look at things that were science fiction 10 years ago, and they are now either reality or close to reality. So people are now seriously talking about the possibility of getting materials from space, from asteroids or from other planets, to look at material shortage. We're looking at devices and systems that could potentially mitigate or alter the course of climate change in terms of atmospheric climate change, sea level rise, looking at different ways of growing things. So there's a huge range of technologies that are there, and they're big trends. And I'd say the last mega trend I'd point to is that the days of just designing something in isolation as a product or a system or a service are really disappearing. The lines are very blurred. So we're starting to think about design for whole life cycles. So when if you buy anything from a toaster to a car these days, you're not just buying the device, you're buying service contracts and support, and it gets updated, and systems are almost always these days very encapsulated, and they communicate with each other, data is involved, and that brings in lots of questions around privacy and transparency and ownership and democracy and globalization and many of these things. So these are there will always be new things that emerge for engineering practitioners and students to consider, and these are what's on the menu today that we have to be considering, and the kind of things that I think will be important to consider in the near future.
And when, especially, these topics, climate, and do we involve students in the conversation when, looking at these issues in joining the conversation, I suppose?
Absolutely. So the E3 project is very much driven by a recognition that we will need to do things differently, and that we can't, to take the example of engineering, or even a subset of that. So Sarah as a civil engineering practitioner, myself as a mechanical engineering practitioner, we don't have the luxury of just thinking about what we do in isolation. We have to think about what other people do and where the interface points are, and that goes beyond engineering into other disciplines. And And yes, we have to design and are designing and have designed the curriculum. I mentioned the Learning Foundry as a space to do that. So these are things that are actively designed within E3. And then I would also note that within the university, we have a climate and sustainability commitment that every student will have to take some content during their time as a student addressing topics of sustainability and climate. So I'd like to say we're ahead of that maybe in some respects in engineering and in E3, but it's also a general feature of the university. I think Sarah probably want to come back in there.
Yeah, and I agree with you. That is like that's the way engineering is, and it wouldn't make any sense to do any engineering if we wouldn't be all the time changing and adapting to the new times and the problems that arise on Earth. And that's the way it's always been, and that's the way it will be. Sorry, I have to go because I have to, in 10 minutes, I have to be somewhere else. I just want to say that I hope this was useful, and anybody that has any questions specific about civil engineering, please email me. And I to wish everyone best luck and for the future.
Thank you
Thanks.
very much.
Goodbye, everyone.
Okay, so I'm going to continue because I have a couple questions related to how to decide what course would be the suitable course for me. So often we, receive questions, for example, I'm not sure if I should go for computer science or computer engineering. And then also students who are trying to decide, or shall I go for engineering or physics or theoretical physics? Is just any tips or that you could share with us when it comes to deciding what course would be the right course for you?
I think it's a really difficult question, and I can't obviously fully speak to other courses and what the detail of what they offer, but I think the best advice is just to start thinking about these things early and to spend time doing things like attending seminars like this, because what is the best fit for any individual student depends on that person. So I think you have to find your way into that and find enough information about the different programs first to see what seems interesting to you, and then follow up that with more questions. I think broadly speaking, a science degree, for example, in physics, science is really concerned with knowledge. Engineering is concerned with practice. So engineers are solution finders and solution creators who are informed by the knowledge and the parameters of science, so they can make good, appropriate decisions about the nature of those solutions. But that's the fundamental difference, I would say, between engineering and science. In terms of the computer science versus computer engineering question, I think to some extent, and this is like a bit of a generalization, but computer science is more the science of computing, computer engineering is the engineering of computing. Now that's one kind of way of looking at it. I would say another way is to say, if you go into computer science, you to some extent have made your decision. You can definitely within computer science do pretty much anything that a computer engineer will do, but not vice versa. So if you go into an engineering degree, you could end up in mechanical engineering or in civil engineering or in computer engineering. So you're not necessarily limited to that. Whereas if you go into computer science, you can specialize in different areas of computer science, but it's maybe less broad in one way. So that would be my answer to that question.
Thank you. And Aditya wants to know, does Trinity provide accommodation for first year? Perhaps Maya or Simon, would you be able to take on the question?
I can give an answer maybe here initially, which is to say that there is college-owned accommodation and priority is given in the allocation of that. The highest priority is international students in their first year of study. So they get the top priority in terms of allocation. And then priorities after that are in relation to first year students, then international students. So there's a prioritization ordering there. And that's important to say, but probably 50 or 60% of our students, maybe even higher. I don't have an exact figure in Ireland, which maybe is different to other universities, will continue to live at home while attending university. So that's not typically the case in many other countries. And Maya, you probably have experiences as an international student, so you might want to talk a little about that. And Simon, I don't know if that college accommodation experience is relevant to you, but if it is, you can come in after Maya.
Yeah, when I was coming in my year, because I'm an international student, I actually got into Trinity Halls, which is the main Trinity owned accommodation. It's a reasonably short commute from Trinity with the Lewis line available, or you can honestly just walk. It's not necessarily provided, like you have to apply for it and everything, and it's kind of what Professor Kevin Kelly was talking about earlier, like it's allocated to international students first and then first years. So usually after your first year, you would leave the Trinity owned student accommodation and have to find kind of your own student accommodation to go to, or potentially find a house or an apartment to rent while you're here. Like Dublin's a busy city, so it's always going to be kind of hard to find accommodation, but lots of new student accommodations have been going up recently pretty close to the city center. So there's kind of been a rise due to the demand for all the students coming into Trinity here. So,
And I guess in my case, I'm very fortunate. I live at home. So I grew up on a farm and I'm still working on the farm in the Midlands. So if there's any other Irish people out there wondering about commuting, I mean, most bus Éireann buses go straight to Bus Áras, and then that's a 10-minute walk onto campus. So it suits my needs perfectly, but I can't really comment on the accommodation situation in Dublin.
Perhaps this is a follow-on question. Besides accommodation, in terms of student life and extra, I suppose, activities, Maya and Simon, maybe you could share with us, for example, some of the club societies that you have had experience with.
Yeah, well, one thing, EngSoc, which is just the engineering society as a whole, is really good in terms of getting social events and meeting other people with generally the same interests, considering we're all engineers. But then, I mean, Trinity has so many societies, even historic ones like the Phil or the HIST, if you're into debating or events of that nature. And then sports is something that I've always done. So I mean, there's every sport as a society in Trinity, really. I play with the GAA, which is the Gaelic Athletic Games. So I play hurling with Trinity. And yeah, I mean, there's so many. There's a comedy society, film society. Yeah, there's definitely a club or a society for you in Trinity.
Maya?
Yeah, kind of in the direct opposite of that. I'm a huge nerd, so I'm in all the nerd societies like board games, video games. I do theater, and even though I thought engineering would be really busy, you actually, as long as you're managing kind of like keeping up with stuff, you have a lot of time, especially at the end of the days when most clubs are doing events, to interact with all of the societies and clubs that Trinity has to offer.
Great, great. I have another question asking are there any specific career development program or resources that are offered to our students?
So we have a careers office, and they do provide services to students and indeed to recent graduates. So they include things like workshops on interviews or preparing your CV. We would also have a number of talks that we would get from industry. So people would come in and talk to our students about their experiences and what they do. So, that can be a useful way to find out what's going on in particular sectors that may be of interest and to ask questions. And beyond that, I suppose, the internship obviously and study abroad provide real lived experience of some of those things. So I think they're probably the answers to that.
Yeah, we have a wonderful career services team that are there to provide, their assistance. And we have a question from Bianca. Bianca is asking, is there a study abroad with Columbia in the 4th or the 5th year of the master's program? And what degree do you graduate with?
Yeah, so I actually just saw that question pop up there. I see also Bianca has another question on how the BAI and MAI degrees compare to BEng and MEng. They're really a direct equivalent. Some Irish universities, to answer your second question first, some Irish universities use BEng and an MEng. In Trinity, we don't. We use the Latin version of those, but they're directly comparable. So and they are professionally accredited degrees, so you can consider them equivalent from that perspective. In terms of the Columbia program, this is an agreement we have with Columbia where students can apply after their 4th year to go and do a 5th year in Columbia and get an MS in Columbia, an MS from Columbia, as well as the bachelor's degree from here. That option is available, by the way, to any student who in 4th year decides that they want to leave here with a bachelor and apply to any other university for a master's program. So in that sense, it's not highly specific. The particular nature of this agreement, however, allows students to engage in an extra piece of work when they go to Columbia, so they can qualify for both the MS from Columbia and the master's degree from Trinity. So it's a dual degree. You get a master's from Columbia and a master's from Trinity, but it's also possible to just leave with a bachelor's and get a master's from Columbia.
Right. There are a couple questions in relation to admissions. Just to recap that what Kevin had said, the application has opened for both EU and non-EU applicants, and EU applicants will have to apply through the CAO, where non-EU applicants will apply directly to the college. It is important to know that admissions for non-EU, I suppose, applications are assessed on a rolling basis. So if you're interested in proceeding with an application, I would suggest or recommend to do it sooner than later, because once the program is filled, then you might be put on a waiting list. So we have an admissions guide with detailed information in terms of the requirements for those of you who applying with, for example, an IB qualification or A-level qualification or Canadian high school diploma, US high school diploma, etc. So we have a very specific guide for non-EU students, and the slides and the recording will be shared with you later, and the address for the guide will be included in the recording and the slides. And so in terms of also this questions on the scholarships, so if you have received an offer for an engineering program, and if you're a non-EU fee-paying applicant, you can apply for the E3 scholarships. So that application portal is also open if you have already secured a course offer, including a conditional offer. You can apply for the E3 scholarship.
There's one question I might just address there that I see, Melanie, which is an anonymous question asking, does Trinity accept transfer credits from other universities, specifically US universities? The answer is yes, but there are particular circumstances or qualifiers around that answer. So Trinity operates a year-by-year system. So if you're admitted into a particular year, you don't get any exemptions for modules in that year. You must take all of the prescribed content in that year. So for us to accept transfer credits from other university, we would only accept it on the basis of a full year. So we have what's called advanced entry, where students can apply to join the program in the 2nd year or the 3rd year of a program. So depending on your knowledge level and your background and your experience, you can apply for one of those, that is entry into the 2nd year or the 3rd year, and that's how we would effectively process prior learning or prior credits.
Right. I'm just conscious of time. So perhaps I could invite both students to share their final thoughts or tips with prospective students.
I guess my final thoughts are, I mean, the one thing is, it's hard to go wrong, really, with especially engineering at Trinity. The range that you get, especially in terms of flexibility under general entry, but also I know that the option was there even as an engineering management student to transfer into the general engineering streams. So I think if you're on the fence and you think you'd like to do engineering, but you're not sure about which one, I think that's what makes Trinity Engineering really good. And you get a good broad taste of everything, and then you get to make your own decision from there.
I just kind of say, yeah, I absolutely agree with everything that Simon said there. It's a great opportunity to kind of figure out where you want to go in life and get a good grasp of things that you might actually get to do in the actual workplace. And just the environment at Trinity in general, I find is very welcoming, and a lot of teachers are there to give you support, even if at the beginning the class sizes might seem quite large. There's a lot of resources at Trinity to help you figure out where you want to end up. So I think it's a good idea to at least give it a try, you know?
Thank you both. I guess, Melanie, we're probably out of time at this point, are we?
I think so. You know, again, the E3 team here is there to assist. If you have any question in relation to admissions or on the courses, you're more than welcome to get in touch. Just to say that we are planning to host a drop-in session for those of you who have applied to the undergraduate engineering related programs. It is scheduled on Thursday, the 12th of December at 12 noon. We will send you an invitation to our drop-in session. This is where you have the opportunity to meet with myself and my colleagues in the E3 team to answer any questions that you may have in relation to admissions or services and supports available at Trinity and on the programs that you're interested in as well. So we look forward to perhaps seeing you at the drop-in session. But thank you so much. I know some of the questions haven't been answered, and we will get back to you after this session. And so thank you very much. First of all, I would like to thank our student Maya and Simon taking time out of your very busy study schedule to join us and share their insights with our prospective students and family. And also, Kevin, thank you so much for giving us a wonderful overview on our undergraduate engineering education at Trinity. And most importantly, I would thank everyone who attended today's session. It is recorded and the recording will be shared with you shortly. And I look forward to perhaps welcome some of you in the near future. Kevin, would you like to wrap up?
No, I think we'll just again thank Simon and Maya in particular for taking the time out to join us, because that's not your job and you are volunteers here. It's Melanie and my job to do this. So, but it is a great help to have the student perspective always. So thank you both for that, and thank you everybody for your interest and attendance today. And we hope we'll see you in Trinity someday. Thank you. Bye.